Hi, I'm Joe Hupcey, and I'm here with the CEO of NextOp, Yunshan Zhu. We're taking advantage of the quiet before the DVCon show floor opens, and I just wanted to catch up with you and learn what's new at NextOp and BugScope since we spoke last.
Yes, since that, we have established seamless integration with all major verification tools. Here at the conference, Broadcom presented a very effective methodology connecting BugScope, using BugScope to connect simulation, formal, and emulation flows. So we have worked very hard to make sure that NextOp assertions and functional coverage properties have minimum simulation and emulation area overhead. So at customer side, we're seeing that when customers bind NextOp assertion into their simulation regression flow, we have less than 2% of simulation overhead. And in a very exciting development, we're seeing customers using BugScope assertions in Palladium flow with zero hardware area overhead.
Wow, that's a great development.
So as a consequence, we're seeing a really good business on the business front, and we're continuing to pick up new customers. We have now more than 10 Tier 1 customers, and I'm losing track of new customers now. And we continue to find numerous RTL bugs for our customers, including post RTL freeze and post silicon bugs. And
that's great. Glad to hear that there's been so much progress and momentum and success. One question, though, that comes up, and you were talking about some of the integrations and such. I know, when people hear the term assertion synthesis or they hear the term synthesis, there's always this thought of, am I going to have to put in a lot of pragmas or some other constraints and such into my test bench or embed it into my DUT code in order for BugScope to pick up on it? How does it really work?
Right. So for us, it's really a push-button solution. So point BugScope to the top-level test bench and the list of your RTL files and press the return key.
So there's no pragmas. I don't have to edit my code or anything like that.
No pragmas, no user hints, no user guidance. I think that's a key of the technology. The assertion synthesis engine identify and figure out the right signals and generate high-quality functional assertions and coverage points. And this automation process really allow designer to uncover constraints and functional coverage scenarios that they did not or could not think of.
Now, tell me a little bit more about the functional coverage. I mean, when you hear assertion synthesis, of course, the temptation is to think of formal tools and such, but there's more to that. It's more than just plain assertions. You really are crossing into providing people with code coverage and functional coverage points.
Yes, so we use the assertion in the general framework as in system Verilog assertions. So that's why we call it assertion synthesis. But we generate functional assertions and functional coverage that both of them actually can be used in simulation and formal tools.
Right. That's terrific. So just a general observation about what you've seen at DVCon so far. What are the trends that customers have been telling you today and earlier?
Yes, UVM. UVM is the buzzword at DVCon, and technologies that are designed to be open and work well with third-party tools are clearly good for customers, and I think ultimately good for the EDA industry as well.
Indeed. Well, hey, thanks for giving us an update, and I hope you have a great rest of the show.
Thank you very much, Joe.